All right, so I got some examples here on substitution rules with indefinite integrals. Again, picking the correct u substitution, you always look for the radical or the quantity raised to a power. When you're wrong, you go back and pick something else. In this case, these are four simpler ones. So again, I see this quantity to the fourth power, so I'm going to let u equal x squared plus 3. And I'm going to immediately take the implicit differentiation of both sides of my substitution. A little bit of rearranging of my red integral there. I'm going to end up with, again, x squared plus 3 to the fourth and 2x dx. And what I catch here is that this is equivalent to this, which is du. This is equivalent to u. So my integral changes to u to the fourth du, which is a very simple integration. U to the fifth over 5 plus c. Since it's indefinite, it has to have a plus constant of integration. And I simply resubstitute for u, which was x squared plus 3 plus c. And again, these are easy problems to take the derivative of. If I take the derivative of this function, it does result in that. So we are set. Yeah. You got to make your u substitutions. And again, as you go, pause me, make sure you're getting the correct answers. 3 more. Pretty straightforward on this one. I'm going to substitute this time. I'm going to leave this. And I need a 3 there. I'll do this in green. I have to keep things balanced. 3 times a third is still 1, so that doesn't change the equation. But this gives me the transportation to get to du, so I can make the integration. Again, 1/3 times u to the 21 over 21. So substitute back. I get 1/63, 3x minus 2 to the 21 plus c. Every time you have an indefinite integral, there will be a constant of integration at each step. Next one. A little more complicated. Again, I see the radical in the denominator, so that's what I'm going to grab. And again, this might be overkill. You might have saw that this right away is du. But I'm writing it out so that we see it, and we saw that this was u. That's what we picked. So I'll write this. I get u to the negative half when I bring it up, du. So that's an easy integral. Add 1, so I get u to the half over half plus c. Substitute back. I get 2 times the square root. I'll go back to a root. 1 plus x plus 2x squared plus c. And again, this is a combination where there's a chain rule portion and a power rule portion. And this is the indefinite integral. Last one, do a trig one. And again, what do you pick? Well, when there's trig, you want to pick the argument typically. So I'll pick square root of t. So I get du, and again, I see this as t to the half, so 1/2 t to the negative half dt, which I will write in terms of square root. I will make the u substitution through 2 steps. A lot of times you guys see it faster, but I'll write cosine u, and then I'm going to write 1 over square root of t dt. Well, it's almost the same. I just need a 2, but if I put a 2 on the bottom, that's a half, then I have to put a 2 outside. I still had the dt here. So then I am left with, when I make the substitution, all right, again, I think of my derivatives. I always work through my derivatives in my head. So I'm going backwards, so I know it's positive sine x. So I get 2 sine u plus c. Last step, substitute back in the original variable, which was t, for u, and we have taking the integral, indefinite integral of cosine square root of t divided by square root of t. Keep practicing indefinite integrals.